Okay, so finally question 15, and it starts off with some questions about tests for different ions. So we've got this complex molecule here, and we've got various different tests to identify what's contained within it. So first of all, we've got the addition of acidified barium chloride solution. Now that's the test for a sulfate ion, which we can see is present here. And when a sulfate ion is present and you add barium chloride, it generates a white precipitate. Secondly, when we add sodium hydroxide solution, we are testing for different positive metal cations. So the only positive metal cation we've got in here is an iron. Now this could be one of two things. It could be iron 2+ or iron 3+. Now, if we look at the formula of what it's combined with, we work backwards. So I know that the SO4 ion has a -2 charge. So for that formula to be correct, then this ion must be a +3 ion. So when we add sodium hydroxide and there's a +3 ion present, we generate a brown precipitate. And finally, when we warm with sodium hydroxide, we're testing for the presence of the ammonium ion. And when we warm sodium hydroxide and ammonium ions are present, we generate ammonia, which is a basic gas, and will turn our paper blue or potentially purple, because NH3, the gas that is formed, is basic. So moving on, we've got an equation here and some results. So it walks you through this calculation to start with. So first of all, we want to calculate the mass of this substance that is produced by heating. So we've got this value, but it includes the mass of a test tube, so we need to get rid of that. So what we need to do is take 28.69 and take away the mass of the test tube so that we're left just with this compound here. So when we do 28.69 minus 22.04, we get an answer of 6.65 grams. Secondly, we need to calculate the mass of water produced. So this is the sample here, which contains water, and this is the value here that is without water. So it's the difference between these two values which tells us how much water has been lost. So 34.09 minus 28.69, so 34.09 minus 28.69 is 5.4 grams. So we're now going to take those two values and calculate the value of X. So effectively what we're doing is comparing the moles of this and the moles of water, and trying to calculate a ratio to find out the moles of X that are present. So we can use masses to start with. MR moles. So this substance, which I'll shorten to that, we know has a mass of 6.65, and water has a mass of 5.4. Now we're given the MR of that substance, 532, and we're given the MR of this substance, which is 18.